what we did the last lecture is an interesting topic we have introduced. The new topic we have introduced was data warehouse design aspects of it, the Kimball approach. And I think also we introduced dimensional modeling, slightly different slightly different than what you might have seen if you have worked on a traditional data warehouse application or database application. I'm sorry, OLTP application. So we have touched some of the examples what a OLTP design traditionally contains, like it's an ER diagram, entity relationship model. So we have an entity relationship model for a traditional OLTP application. When it comes to data warehouse, we talk about dimensional modeling. So in the dimensional modeling, we look things slightly different. Okay, so I want you to visualize the concepts clearly, because I want you to clearly understand, okay, I am still working on a database, okay, because the technology is growing or changing rapidly here. So we still want to see that data warehouse applications that we have in the organizations predominantly built on a traditional data that you have captured in the organization. So, okay, based on the business model that you have, based on the business type of activities that you do, so you capture some transactions in the OLTP applications. So, use those data values, for a historical period of time, and then capture that into your data warehouse, and then using the data, real data, you're not imagining anything here. Of course, you might extrapolate for a future, 2 years down the road, 3 years down the road, or next quarter, or rest of the year forecast and things like that. You might be extrapolating to certain extent based on the facts that you have gathered from a OLTP system into the data warehouse. So I think it is clear now. I think this is we all need to understand this concept so that it's easy for us to understand the rest of the points, because you always remember we are not a real-time system. Data warehouse is not a real-time system. Just keep that in your analogy, because if you take out that point, that, okay, we are not going to do any real-time processing in the data warehouse, then your thinking process will change, because you got to look at this. Okay, if a particular data is missing in the data warehouse, let us say I have 1 day's worth of transactions are missing. It's not the end of the world. That data is still there in the operational system. So you can go back and get it. So you don't need to be panicked. Of course, there are some people get panicked and things like that, but if there is a catastrophe that something is missing, in case of operational system, if let us say if they process some orders, and if you have not captured those orders, and if people have to re-enter those orders in the same sequence, it's going to be a disaster. It's going to be a big hassle. Let us say you're in an OLTP system, you're processing orders at 8 o'clock, and then your system crashed at 10 o'clock. You don't have a backup from 8 to 10. Okay, so normally we don't take backup every minute. We typically schedule backups every 6 hours or every 12 hours, or sometimes once a day, depending on the business nature. Let us say you have a daily backups for an OLTP system, and the backup starts at 4 o'clock in the evening or 6 o'clock in the evening, and you process in the morning, and then by 4 o'clock in the afternoon, system crashes. So most of the day has gone. If your database don't have a way to recover those transactions that were happened in that whole day, so what's going to happen is everybody is going to be chaos. The management will be chaos, business will be chaos. How am I going to enter? I don't remember everything, and it's really a disaster situation if you don't have a proper backup and recovery mechanism established for those systems. In case of data warehouse, it's completely different. Let us say you have captured, you have loaded everything in the data warehouse, and business is doing their analysis. They're checking away. They processed. They did a lot of analysis till 4 o'clock, and system crashed, and you lost the data, and you don't have a backup because you take a backup every evening 6 o'clock. The same scenario like what we just discussed for OLTP application. Now we are in a OLAP application, data warehouse. You take it back up to 6 o'clock every day. That means your entire batch processing has run, and the entire day has gone. At 4 o'clock, system crashed. So what is the situation for us? Okay. Raja, you're complaining. I can't hear well. Again, let me take a quick check. How is the audio and video? Can you just do a check marks, please? Is it good? Problem? If you have a problem, give me a class. Okay, so looks like everything is good, Raja. I think you might have to wait. Sometimes, again, like I said, I would recommend you come like 5 minutes before session starts, so that, again, this is a WebEx technology, and it just takes some time to get everything loaded and things like that. So probably that's what it is. So, again, as you understand, we started at 20 users. Now we have almost double the users. The people are coming into the meeting, into this audio video conference. So it's just modulation. So it will take a while, and then I think slowly set up for you. Okay. In any case, my point is clear. I want you to compare. So what is the situation now in case of data warehouse? So the same scenario at 4 o'clock, data warehouse crashed. So what would be the scenario for data warehouse? So assuming you don't have a proper backup and recovery. So I said in the OLTP application, if you don't have a proper backup and recovery mechanism established, you are done. It's a disaster, catastrophe. It is going to be escalated all the way to the up in the management, because you have to go and ask the business users to re-enter the orders, and claims, whatever it is, it's just a disaster. So what would be the scenario for a data warehouse application if the same scenario happens? What would be the case? Okay, somebody would like to speak up on that? Anyone would like to speak? What do you think? What would be the situation if the same scenario happens for a data warehouse at 4 o'clock system crashes? What would be the scenario here? Is the same thing, catastrophe? It will be escalated all the way up, or you can manage the risk. So how can you manage the situation? Anybody would like to speak? Failover, yeah, there is no failover. I'm telling you, we don't have a recovery mechanism established. That's what I'm telling you. In case of OLTP system, we don't have a recovery system. Then it's a catastrophe. It's escalated all the way high. The same scenario for data warehouse. It's crashed at 4 o'clock in the afternoon. You don't have a backup recovery established, or the recovery mechanism is not going to work. We know very well. So what is the option that you have? Rerun the batch after the DB is up and running. Okay, that's a good point. Somebody said, Manoj is telling, rerun the batch job after a system is up. Export data into flat files daily. Maybe we have master slave. We don't have master slave, nothing. There's no failover. There is no recovery. Everything is, that's nothing worked that day. Okay, assuming that. Okay, so I think one of the points Manoj is telling, rerun the batch job that we ran in the last night, and then we should be fine. Okay, that's one approach. Do a full load again. Okay, that is Umesh is coming. Sunil is telling restore the last day and recent backup. Yeah, if you go back to recent backup and restore, then you might still have to rerun the batch jobs because it will go back to the point, and then you need to catch up the rest of the data from OLTP system. Okay, that is another approach. Yes, I agree. Vinayaka, you're in the right path. Any other thoughts? Okay, anybody would like to speak on this scenario? Again, feel free. Again, there's nothing wrong. You're just giving your thoughts here. Okay, good. That's fine. So my take on this here is, I want you to be. I don't want you to be panicked in the data warehouse situation. If this happens, again, I don't expect this to happen every day. In case this happens, so always remember, we are not the master system. We are a slave system. The data warehouse system is a slave system. So if things happen to the master system, there the big panicky scenario will happen. But because we are a slave system, our data is not generated by transactions that are happening every minute. So our data is depending on some other master system. So if something fails, that means, let us say, if the system crashes at 4 o'clock, So you have to clearly explain why the system crashed to the management. There is a problem. There is a hardware failure. There is nobody can stop that. Okay, the disk drive crashed, the processor failed, whatever it is. Those kind of scenarios could happen anywhere in different applications. So there is no management will be upset because this scenario happened. We have to address how are we going to mitigate the risk. So now we go back to the management and say, look, so this happened here. So we go back and say, we are going to go back and then do the backup from the previous and then restore because that was good. Yesterday's backup is good, 6 o'clock. We restore from that, and then from that point, we rerun the entire batch job. So now you know exactly how long it took already last night based on the batch schedule. You can already project to the management, project to the business users saying, look, so whatever analysis you have done today is still good. There's nothing wrong with those numbers. The only thing that I'm going to tell you is, you can't use the system for the rest of the day or however many hours it's going to take, okay, to restore yesterday's data. And then after that, you have to run again today's transactions. So you calculate all those things and clearly project to the management and the business users saying that, look, this is the problem happened in our data warehouse application due to whatever reason it is. So we are going to recover the system as of yesterday backup and we restore everything from yesterday, and then we're going to rerun today's data. When you come tomorrow morning, don't expect the system to be available at 8 o'clock. It will be available by 10 o'clock in the morning, 11 o'clock in the morning, whatever it is. Give a realistic estimate based on the numbers that you already know and based on the historical figures that you already know. So here you see the difference. You don't have a catastrophe here. You don't have to, nothing will get escalated. You're also telling them whatever analysis you've done today is correct. You're not discounting there is something wrong there. The only problem is you have no data warehouse system for an extended period of time from 5 o'clock in the evening till next day, 10 o'clock or 11 o'clock. You don't have the data warehouse for running reports. Other than that, it is not a big thing. So I want you to visualize this because I want you to keep thinking, because I know we talked about data warehouse design, dimensional modeling and all that. So in addition to that, we also in the back of our mind, we need to think, what are the type of systems we are going to deal with? We already know it's going to be very large. We already know very large fact tables, which will be sometimes 500 gig or 1 terabyte. I think one of your friends said in the class 1.5 terabytes. So we have to deal with those scenarios. And then we have very wide dimensional tables with hundreds of columns. And when you have that many columns, how the indexes are going to work, how the performance is going to impact. So all those things should be keep thinking. All those things should be coming to our minds. We're dealing with a system with this complexity, but when something happens like this, we also have to be calm and make sure how we can address the scenario and give a proper, meaningful result. Okay. Oh, okay, so that's a good point. I think, I'm sorry, Rajeshwari, let me catch my book. Okay, that's a good question you raised, ISBN of the book. Let me catch that book quickly, 1 second. Okay, so here is the book that I have. Some of you might have seen this. I'm going to take a snapshot of this book, the ISBN number from this, and then I'm going to type so that you can take a look at it. Okay, so that if everybody has the same number, or so you try to get this number or close to this. So there are several ISBN numbers out there. 47046 207. That is the ISBN number I have on this book, unless there is something else. Okay, 462072, yes. So I'm in front of it, ISBN in front of it, okay? I'm sorry, again, I've been replying to some of the people who asked those questions in the Taxila. I was not able to go to the Taxila and update it, but again, this is the book that I have, so I think you can see it. So if you can get that book, that's great. Okay, so coming back, so again, the reason why I want to touch this point is because I also not only reading the book, I want you to visualize. I want you to see, get the. That is an Indian reprint. It's a Indian book only. I got it from Indian publisher. So they sent me this book from India. So it should be an Indian book. So though we don't need any mechanism on the data warehouse. Further, we should do it manually. Yes, I think like Jenish, that the question you're asking, I'm not sure manually what is that means, because again, the point I would like to say here is, the example that I gave you is because I want you to visualize the subtle differences between a traditional application and a data warehouse application. At any point of time, there should not be any ambiguity in this, because there is a reason why we are creating the fact tables. There is a reason why we are creating a dimensional tables. There is a reason why we are creating a star schema. Our textbook clearly talks in chapter 10, I think, it clearly talks about star join, star index. So the way that you make these tables connected, in a star format, star schema, so what's going to happen is they will have a very strong join relationship, and then when you try to pull the data out of the star join, they come really fast. Even though the fact table is very large, the dimensional table is very wide, the database will work in a parallel mode, and it gives the data really fast. Okay, so I think I want you to visualize those points as we go, and also read the book. So it will be helpful. So we are going to continue what we have studied in the last lecture. Again, try to understand what is the primary key. I think those of you who have taken a database class, very well. Every table in a database will have a primary key, and that means the primary key is unique. And if you have a primary key, automatically the database will create an index for that. And if you're trying to access through that key, the data will be faster. So those are all the database characteristics. So what is a surrogate key? Surrogate key is also a primary key on your table in a database, data warehouse context. Okay, and the surrogate key is not, you don't, when you create a surrogate key, database doesn't create automatically an index. You have to create an index, because it's not a primary key unless you define that as a primary key. Then index will be created automatically. But as we know, a fact table will have a multiple keys embedded in the primary key. As we know, because we have a star schema. In the star schema, fact will be in the middle, and then you have the dimensions surrounding it. So for each of the dimensions that you're connected to the fact table, there will be a key, because you're joining. There is going to be a key that will be allowed to join these dimensional tables in the different in the star schema. So a fact table will have a multi-valued primary key. Again, these multiple values within the primary keys are the surrogate keys that you have created when you're creating a dimensional table. So we touched these points in the last lecture. I hope you got those points and read the book, and it will be clear. So, let's go to the slowly changing dimensions and rapidly changing dimensions. I would like to introduce those things, and then spend some time on retail grocery store, and also some other practical examples we would like to take it. So I just put this slide again so that I want you to see if anybody has any questions on this. Again, there is no meaning for the surrogate keys. It is, like I say, when I say primary key, by default, database systems know that it has an index, it's a unique, and all that. When you say surrogate key, it is a key that you have introduced. So there is no meaning to the database. So you need to tell what it is for the database. It is a surrogate key. That means if you want to be an index on it, you create an index on it. You can define the surrogate key as a primary key. Whatever you want to do, you can do it, but there is no meaning for the database. It's just a numeric sequence value that is stored in it. So you can't store alphabets. It's purely numeric, so that it also gives a most optimal retrieval performance for you when you're trying to access the data using this. Okay, so those are the basic points I can tell at this point for the surrogate keys. and you are introducing the surrogate key. Another point I would like to highlight here is, if I ask a question quickly here, where do we create the surrogate key first time in the data warehouse? Which table are we going to create surrogate key? Is it in a fact table or dimensional table? Okay, somebody wants to speak on that, or you want to type? Okay, majority of them are typing dimensional table. Okay, anybody else thinks other way around? That's good. Okay, so I'm very happy. Okay, so it's a very clearly that's fine. I think some of you are still thinking fact table. That is not the correct answer. Again, good thing you're putting that so that you will never forget. So that is also another point I always tell. You tell something that your instinct tells, and if I tell something wrong, then you will never do that mistake again. That's a good point. That's a good analogy too, in my experience. So I think some of you are told it's a fact table. It is not a fact table, y'all. That is a good point, because this is another point I want to be clear here. Surrogate key is created every time there is a new dimension entry comes. Okay, so we're going to touch this point in the next lecture, when we're talking about the ETL and all that. But, the point is very clear. When there's a new record coming into the dimensional table, that is the time you're going to assign for every natural key that you're getting from operational system, OLTP system, you're going to assign a surrogate key. So what does that mean? Let us say you have a customer. So for a customer, what is the natural keys? Customer ID. Let us say you have a dealer network. What is the natural key for the dealers? Dealer IDs. If you have a student database, what is the natural key for a student database? Student ID. So these are the different IDs. Those are unique in the operational system. So when that particular data is brought into the data warehouse, where does this dimensional data sit? It will be in a dimensional table. When the dimensional data is coming in, so let us say a new record is coming, let us say a new student is created, new customer is created, new dealer is created, new vendor is created, new product is created. Whatever of these things happens in the source system, when that transaction comes down into the data warehouse, that is the time, okay, there's a new natural key coming. So then it is not there in the dimensional table. Then I create a new surrogate key. And how do you create a new surrogate key? Go back and look at the surrogate key that you created before, increment by 1. That is your new surrogate key. Very simple logic. That you create a new surrogate key when you have a new entry coming into the dimensional table. So when you have a new entry coming to the fact table, you don't create any new keys. You only go to different dimensional tables, find the corresponding surrogate keys, and build your multi-valued primary key. Let us say there is a transaction happened today. So what is a transaction? Student X, like I said, I will take an example here that I see right on my screen. The student ID who didn't put their name, 2014HT13549. I don't know who you are, but you are a student at BITS Pilani. I know you very well, and your ID is 2014HT13549. So when that ID comes into my data warehouse, let us say you took a data warehouse class, and your ID came to me because you took an enrollment into the class. So as soon as I get the record, so what's going to happen is I need to enter into my fact table saying the student is entered. So now I got an enrollment transaction. So by looking at the enrollment transaction, I have a student ID, I have course ID, I have the term and all that. So student ID I take like 2014HT13549. I go to the student table and find what is the surrogate key for that, because surrogate key is there. So I'm going to use the surrogate key when I'm going to insert into the fact table. I'm not going to insert 2014HT13549 in my fact table. You will not have any visibility of that ID in my fact table. So fact table will only have the surrogate keys, no place for natural keys. Natural keys that come from OLTP systems are only going to stay in the dimensional tables. Hope this point is clear now, and otherwise go and read the book and listen to my previous lecture. So I want to make sure this point is very clear. I don't want to make any mistakes when a question is asked like this in the exam. Where does the surrogate keys are created? Is it in dimensional fact table? You got to have no ambiguity on that answer. So very simple, straightforward question. Okay, that's good. So let's move on. So this is very good point. And then it's a very simple thing. It is a primary key. Surrogate key will be a primary key in each dimensional table. There is no question. But the surrogate key that you create in a dimensional table will be one of the part of your primary key in your fact table, because each and every dimension is connected to the fact table. Okay, so I think that is a very high level concept. I think hope everybody got it now by this time. So now then we introduce the slowly changing dimensions. So what is the slowly changing dimensions? Why does it come? Because you got to understand one thing. The dimensional table entries, they don't change every day, every minute. Let us say I have a student. Okay, student ID, a very simple example I took again, 2014HT13549. So when you enrolled into the university, you have created your student record, your address, your name, your region where you're coming from, and what is your interest, whatever it is. Okay, what is your background, where you work, all of that information is created. So how many times you go and update your student record in the course of your study at BITS? Probably once, twice. Let us say you're working for a company now, and in the 2 years before you graduate from BITS, you might move to a different company. You might go back to BITS and saying, look, my employment has changed, please change that. So how many times do you change this information? So very less frequently changed. So the dimensional values for the records that you have in the dimensional table, they don't change that fast. They do change, but they do slowly change. But again, you also have to understand one more point. Not every attribute in the dimensional table is going to change too. There's only few attributes that are going to change, because if you have a name, I don't think you will go and change the name every minute, every day, every other day. So if you're a woman, when you're married, you might add a last name. So in once in a lifetime. So there is a chance you're going to change some of the attributes in the dimensional table, but they're not changed that frequently. So that's where the slowly changing dimensions come into picture. But when these do change, so what do you do? Let us say in an operational system, a name is changed, the last name is changed. So what do? They don't keep what is your previous last name in the operational system. They try to override. I don't care what is your last name before. I just override. I just want the name. Let us say you moved on to a different address. You moved from Tamil Nadu to you moved to Rajasthan, or from Rajasthan you moved to Madhya Pradesh, whatever it is. In operational system, I really don't care where you move. I just need the address if I want to communicate with you. But in case of data warehouse, if I want to play with this data, if that data is going to make sense for me to track historical results, that is a very important point. When you see these three-dimensional slowly changing dimensions, so I also want you to decide which type of change you need at what time. That is also a very important point. Don't assume that you're going to pick and choose arbitrarily here. So there, in a dimensional table, let us say you have 100 columns, 80% of the columns will still apply type 1 change, because most of them are override, because you really don't care. Okay, even in data warehouse terminology, you might not be that much be interested in the data that comes in the if it is changed because you're not going to use that for any analytics. If that is the case, it will be type 1. So like I said, 80% of them will be type 1. So some percentage, very low percentage, will be type 2. That means you would like to maintain the history so that that historical data is going to help you do the analysis, and provide some strategic decisions, some managerial decisions, whatever it is. And then type 3, I think we also talked about it. At any given time, you can only have, one previous historical change. That means, you can have a current and previous. That's it. The reason again that people do is kind of a soft change. Sometimes people would like to see what is my previous value, and they would like to see the analysis of data, how that is going to impact before they make the permanent change. Okay, so it's just some of those examples there. We will talk about it and we'll see. Type 3 is a soft change, and then it will be used accordingly. Okay, so can you give me an example for type 1? Type 1 is anything, because if I don't want to keep, let us take an example here. in this example, home owned or leased. Let us say your home is owned or leased, or is a home new or old, whatever it is. I really don't care about this. I don't. It's just information that is there. It could be if there is a change. Let us say today I'm staying in a rental apartment. Tomorrow I go to the house, and it's just information that we would like to capture for our analysis purpose. If our company has some benefits given for people who are living rental apartments, pay some money, something like that, then I would like to use that if that is the case. So that's the only thing that I'm using. I'm not going to do analysis how many people living in rental, how many people living in their own homes and things like that. Then I really don't care to maintain this. If there is a change here, I just overwrite it. Why do I maintain a historical data for this? So those are the decisions that you make based on your requirements. Okay, always remember, whatever you're designing in the data warehouse, you're not designing, sitting on a seashore or something like that, on a beach or something like that. You work with the business, get the requirements. Based on the requirements, you think through and then put together a structure, put together a design for the data warehouse. Okay, so that is a very simple, straightforward example that I could give. For type 1 change at the page. Okay, so again, the points I would like to clearly make you aware is type 1 is, majority of the changes will be happening type 1 in the dimensional table. There will be some percentage, very minor, few attributes will be type 2, and then very, very, very few, like 1 or 2, will be type 3. Assume every type 3 you're adding a new column. Okay. And also probably the effective dates and things like that. So just bear in mind, if you have a type 3, it means your table is going to be more wider and wider. So there will be very few, and in my experience, I've seen not more than 2 type 3 changes in any one-dimensional table. I have seen them, but it's not like, okay, I have 10 type 3 changes in one-dimensional table. Okay, so it's very important for us to also understand these kind of things so that it's easy for you to make decisions. It's not, and then based on those decisions, you're going to program your database loads into the dimensional table. Okay, every record coming in, if there are some fields with the type 1 and there are some fields with type 2, you're going to take that column. If there is a change, then you have to apply the rule of type 2. If there is a change in that column, you do apply the rule of type 3. So we're going to touch that in the next class, when we're talking about ETL. Okay. So then I also would like to highlight the rapidly changing dimensions here. There's a slide on that for me, but I think we took this example in the last lecture. If you have any questions, please raise, but otherwise it's a very clear example here. So again, I want you to clearly understand here, this particular customer, this is the natural key that you see, 31421. This is a surrogate key you created. So, a very good example for this is, so here, the district is changed from 3 to 31. The management would like to track what sales this person has done when he was in district 3 and compared to district 31. So it's a type 2 change. So it created a new record and new surrogate key. So what's going to happen after this point from 2006 of January 2nd, any new record that comes into the fact table, any new transaction that comes to the fact table, so what's going to happen is the fact table entry will have this primary key and natural key coming in, and then when you look up the dimensional table, you take the latest surrogate key link to the latest, the current effective date values. So you don't pick up 1552 here anymore. You're going to pick 2387 here. From this point onwards, any new records coming for this particular customer ID, you're going to have a new surrogate key or 2387. So I think we took this example already last time. There are different entries coming here, and when you're searching in the dimensional table, so you're going to search for this key. If you're just searching, what are my sales for 31421, then you will find both these records, and when you join these, you'll get all these records, and then you sum up all these will give the total. But if you want to find what is the sales that was done by this customer in this district 31, so then when you do that condition and customer ID is this and district 31, then you only end up with one record. You don't have two records anymore because your search criteria from dimensional table will result only one row, which is this row. when you join this with this row, this particular table, fact table, so you only get one row here because this is going to match only this row. It doesn't match with any of this, so it will only result this, and automatically you will get this is the result. So you can easily tell what are the sales that was done for this customer in District 31. Now if you want to change the criteria and say what are my sales for this customer when District 3, so then this will only give this row, and then when you join it will result these 3 rows, and then add up these 3 will give you a total. So it's very important for us to understand this concept. Why do we create this type 1, type 2, type 3? Again, only for slowly changing dimensions. Okay? If it is rapidly changing dimensions, there is no meaning for this, because if I am changing something today, again tomorrow is changed within one day, what big deal? You know, you're not going to really make use of that data analysis. Okay, that is why when you're doing the rapidly changing dimensions, you really don't you don't really process. You don't really it doesn't make any sense to create these duplicate rows, create these duplicate columns and things like that. Basically what you do is whenever there's a rapidly changing data, this is a very good example from our textbook, you can see from chapter 11. So I picked up this slide right from the book. So example, so here we have a customer table, and again, it's a very large table in some of the organizations that have a customers, very wide range of customers. When you have this and the things are frequently changing, the behavior patterns are frequently changing from the customers, then what they do is if these are changing rapidly, then they push them into a different dimension. Okay, you see here, they're putting a different dimension and they put a different dimension here. So if this is a very large dimensional table with millions of records and it's a rapidly changing dimension attribute, there are some of them rapidly changing. So best way to do address this scenario is put them into 2 different tables. Again, there are 2 different main advantages by doing this. One of the main advantages, this table is very large, a million records, and if you want to go and update, it's going to take time. So it is better to move away the rapidly changing attributes to a different table and assign a proper key and then link it to your fact table. So this is another way to address. Okay, so that is a very good example from our textbook. You can take a look at it. Customer is a customer dimension is a very good example where you could do this, and sometimes the product dimension is also another example because you have too many products that you offer in your organization, and that is also could be one of the possibilities for a rapidly changing dimensional criteria where you could break up one big dimension into 2 smaller dimensions and join to the fact table. So you're still achieving the same benefits, but you're just breaking it so that you can avoid the performance issues. So I hope it is clear on this concept. I think yesterday, Raj Kamal, yes, you're right. Slipping into another table will increase the query time, but I agree 100%. But as you have a different key here, as you can see here, behavioral key directly linking to this, and customer key directly linking to this. So anytime you're trying to pull some of the data elements from here, you're going to use the key linking this table, so it will be efficient. And I'm sure there will be slightly, there will be some impact, but it is very marginal, and also the overhead that you're going to have in updating this large table is going to be compromised here. Okay, so let me take a recording break here. It's already 30 minutes plus, and then we'll continue. Okay, so let's get started here. So I think yesterday some of you were asking about a question, what is this hybrid? So hybrid is again a concept that you could combine type 2 and type 3. So again, do you really use it? If you need it, you can use it. There's no question about it. As you can see here, you also create a duplicate row here, another record with a key, and then also you're maintaining old category and new category with an effective date. So it's a possibility you can do it, but again, I have not seen one myself, but there is a possibility that you could combine type 2 and type 3 and make use of that if there is a need for that particular scenario. Yeah, the primary key of the fact table is a combination of the surrogate keys that you have in the dimensional tables. Okay, it's not a natural keys. You will only use the surrogate keys from the dimensional table that you have. So that is a That is how it is. For example, if I look at this example here, so you see here, even again the dates were given here, but this should not be the case. It should be the surrogate keys here. Okay. And this is surrogate key. This is surrogate key. So just bear with that. Okay, so then coming back to the again date dimensions, we touched already last lecture. We have discussed this extensively because again, most of the data warehouses will come with the default dimension for the date, and this will have all possible options of dates so that you can do any kind of analysis that you can do. The behavioral key, I don't know, Bindu, you can explain that. I was telling surrogate key is an artificially introduced key by yourself in a data warehouse. A behavioral key, I'm not able to understand the context here or the meaning of that. You're referring to a natural key that is coming from the operational system. Yes, a natural key will not be part of your surrogate key. We try to use, the surrogate key combination is kind of, you use surrogate keys in your fact table. Okay, we'll also do some examples in the next lecture when we do actually ETL, so it will be clear for you. Okay, so we talked about this a little bit, in the last lecture too. Views, again, a view is another important aspect in the data warehouse. There are two types of views that I can think of in the data warehouse. One is a normal view. A normal view is nothing but for every view there is a query behind it. So the reason why we go for views is sometimes you want to join two tables and then you want to use that as your input for your processing. So in order for you to do that, it's easy for you to define that on the database level, and then so that every time you refer the view, by default the query behind that view will be run and the data will be materialized for you. So at that point of time. So that is a regular database view. But in case of data warehouse, we also talk about materialized views. A materialized view is one in such a way that we have a query behind it. There's no question about it. It's a kind of it's a join query, whatever it is. It's a simple straightforward query, whatever it is. There is a query behind the materialized view, but the difference between a normal view and a materialized view is a normal view is going to pull the data from the database at the time of execution, at the time of reference. Whereas in the case of materialized view, so your query behind the view is already run, extracted the data. The result of that query from behind the view is going to be physically stored on the database. So a materialized view is one. The data from that view is already materialized on the database, so that it is available. When you click it, the data is right away, it is available. It's not going to go and join and pull the data at that moment when you click the view. Okay, in a normal view, it is going to pull the data at the runtime. In case of materialized view, you pull the data during the defined time. When you define the materialized view, at the time it will be pull it, physically store the data in the database, so that when you refer that, it's like a regular table, like any other table. So the advantage of this is, you're creating these materialized views based on some of the business criteria. Let us say I have these 10 users, they run this query every day that joins these three tables. Every day morning they come at 8 o'clock and they run these three tables, very huge tables in my data warehouse, and I know they're having some performance issues. I can think in this direction, probably why don't I know these guys are doing this every day. Why don't I join these tables beforehand the way they're doing during the day, the batch time, and then create that data physically on the table, on the database, so that when they come in, they can just refer the view, data is already materialized, just pull it. And you can also create indexes on it. Acts like a regular table. So we, again, some database management systems doesn't offer the materialized views, but like Oracle and some other database management systems support materialized views. So when the database management system support, it does automatic refreshes and it does a lot of things for us. But in case if your database management system doesn't support that, you have to manually create those scripts. You have to manually create those. You have to manually manage all the activities. But there are some database management systems, they do perform this. Okay, so it's very important for us to understand view, materialized view, because it's used extensively on dimensions, and the reason why we do this because let us say I am running a report. Okay, when I'm running a report, we all know that reports will have drop downs. The majority of them reports will have a drop down selections. So not everybody want to key in the values for your reports. I go and select. Okay, I want the month 1 of this year. I just would like to. I don't want to write January. I would like to go click and drop down month 1. I pick it. Then I go to the next. Okay, this product ABC. So I don't want to go and type ABC. I would like to go drop down the products and pick one of the products or a group of products, whatever it is. So it is a user intuition. We always like to pick. You pull the drop downs from a database. Okay, where do these values come? So most of these drop downs are sometimes fixed. Sometimes they come from the database itself. Because otherwise, we select the product IDs. Where do these things? It's better to pull the product IDs from the database. If you don't pull it from database, you put them as a fixed values. That means every time you have a new product, you have to go and refresh this report to add this new product into that a constant value. So it is better to get as dynamic as possible these things in the report. So that is why I'm telling you, it's better to use some of these materialized views for those kind of scenarios, so that when somebody tries to drop down, it doesn't take forever. If you don't have this join, and if you're trying to do joins on the time when they click drop down, it is going to take 10 seconds and people get frustrated. Why this drop down is taking 10 seconds? I'm sure you have that feeling. I've seen many cases when we're using the system, some of the reports, when I try to drop down, it just takes 5 seconds. Even the 5 seconds, people can't tolerate because people's expectation of the drop downs are instantaneous. So how fast we can get. So whenever if you see those kind of scenarios, immediately you should think about materialized views, and it is a very, very nice concept, and we use extensively in the data warehouse. Okay, I'll leave it there. We're going to touch those topics probably again in the later lectures. Gen dimensions. Again, the reason why we have this, okay, as you have seen our design strategy, we are putting everything in the dimensions. All the descriptive attributes are in the dimensions. All the measurements are in the fact table. Okay, so when you're designing from an OLTP system, we go and look at the OLTP system and working with the business and say, okay, what are all the facts? What are all the dimension values? Okay, what are the things that you would like to do the analysis on? So these are all the information you gathered, and you pulled some of the dimensional attributes, put it in the dimensional table. You pull some of these measurements, put it in the fact table, and still there will be a lot of information in the OLTP system. There's a lot of data values. There's a lot of flags. A lot of miscellaneous categories. All of those things are there in the operational system, and you might think they might be using those things. Okay? If you think they're going to use them, but they doesn't really fit well in a fact table, or they doesn't really fit well in a dimensional table, so in that case, what you do is instead of mixing apples with oranges, we put them in a separate box so that they stay their own standalone. So that's what we call the Gen dimension. Okay. Again, this is a name that authors use, and we just follow that. Then the other concept that I would like to introduce here is degenerate dimensions. So what is a degenerate dimension? Just like Gen dimension, there are also some other attributes like order number, invoice number, order line. Where does this go? Because they're not numeric. I know there are some of them numeric values, but they're not like measurements. Okay, so I don't really do anything with the measurements, but I need sometimes that information so that I can uniquely distinguish order numbers, uniquely count what is the number of lines per order, average number of lines per order, average price per order. If I want to do that kind of things, I need that information. So where do I keep this kind of information? So we keep this information in the fact table. Okay, so and then our textbook also has a good example for this. We keep this information in a fact table at the very at the end after all your measurements, so that it will be there. And when you're doing some analysis, it is available, so you can use that data for your data analysis. Again, when some questions like this, happens, average number of products per order. What is my total? How many number of lines that we have created in average per month? Something like that. When you want to do this, so we will do those kind of examples in the degenerate dimensions. Okay. Again, Gen dimensions is very simple. there are some attributes in the OLTP systems that doesn't properly fit in a fact or a dimensional table, and then you would like to still capture those things for some analysis. Then you will use that as we create them a separate table, call it junk dimension, put all the flags there, and then we use that for analysis. So whatever doesn't properly match with information. Again, degenerate dimensions, you're adding those values will increase the size of the fact table. Again, I'm not really worried the size that much in the data warehouse because we're dealing with anyway terabytes of size of data. So adding one field is going to add a little bit. That's fine for me. At the same time, it is going to give me flexibility to do some analysis for my users. I will go for it. Okay, and just for fun, I don't add anything. If I'm adding something, there is a reason. I mean, there is somebody who wants to use it, and that's the reason why we want to add them. So it's not. Always remember, it's not that we're going to add just because we're going to use it just like that, those fields. Okay. So the next thing, aggregates. We have a very detailed topic. I'm going to touch on aggregates. Degeneration dimensions are not part of separate table. They're part of your fact table. So we call them as a degenerate dimension because they're not fitting in the dimensional table. They're kind of a descriptive sometimes. They're not, like it's order number. It will have some characters, some numerics, things like that. So they don't go to the order table or order dimensional table or whatever dimensional table that you have. They will stay in your fact table. So that's why degenerate dimensions are, it's another entry in your fact table. We can take a look at it in our textbook. There's a good example. Go through that. So aggregates, we're going to talk excessively in our coming lectures, but always remember, so we are not stopping our analysis at the fact table level. We are going to build aggregates. So why do we build aggregates? We build aggregates to improve performance, and then granularity. Sometimes you have gone too deep, too much low-level granularity in your fact table thinking, so that you don't have to lose any of the business flexibility. But don't expect that everybody will run analysis at that level. Okay, I have the data captured at the part number level, but how many times I go and do the analysis at part number level, and I'm doing strategic decisions. At the VP level, he will not go and look at what is this part number is doing. He would like to see what I did last month. He would like to see what I did last quarter. So it's very high level. So for sure there is a big role for aggregates. So address is not part of a junk dimension. I think I'll come back to the questions quickly in a minute, and then we'll go back here. But before I go to the questions, let me focus here. The aggregates, like I said, we are going to have a lot of room for aggregates. And again, the point that I would like to highlight here is, we build aggregates only when necessary. We don't like that build aggregates because we look at the business user behavior, we look at business user retrieval patterns of the data, and we see a lot of them are doing these aggregates on the fly. Then we go and look at it, talk to the business users and say, look, let us go and build an aggregate so that it will give a really good performance. I have a good example that I can tell you. I think last month or 2 months ago, one of my business users complained about a performance on one of the finance cubes. Okay, when I approached my AMS team, application maintenance support team, again they're from India and they're supporting us, our organization. So when I asked them, can you look at this? Why this suddenly the performance is an issue? It is taking longer than 10 minutes. Sometimes it takes 7 minutes. It's just all over the board. So then they started analyzing, and I said, let us compress the data. We look at everything, and then they said, probably PC, if you build an aggregate, because this is what they're trying to do, an aggregate might help. No wonder. When we build aggregate, the same query that was taking 6 minutes, it is dropped to throw some number, guess some numbers. It was running 2 to 3 minutes, sometimes 6 minutes, sometimes 7 minutes. After building the aggregates, you're too aggressive, 20 seconds now. We dropped down to like 70 seconds, like 1 minute, 10 seconds. And one query, I think it dropped down almost 59 seconds, close to 60 seconds, 1 minute. So again, the reason I'm trying to give this example is because I want you to have all these weapons in your hands. but don't use the weapon every time. The weapons are not going to work for, these weapons are not applicable for every scenario. Okay, so you got to keep thinking when situation comes. You should imagine, you should visualize. Okay, should I create a materialized view for this because it is taking this, or probably aggregate, probably compression, probably index. All of these things you need to visualize. You need to try sometimes, and then come up with some solution. Okay. Then again, we talk about these fact tables. Again, we're going to deep study these things as we go. So as we say, transactional fact tables are very common. There is no question about it. Most of the organizations will have a transactional fact table. That means fact tables at the transactional level. For each transaction that happens in the operational system, it will come down into the fact table, and you have an entry in the fact table. And a periodic snapshot, sometimes what we do is we try to pull the data by period. We have a data warehouse, and based on the feedback that we got, all the users using that particular cube, that particular analysis, they only use on a monthly basis data. They don't really go down. So probably what we'll do is periodically we just create one every month. You run the data once a month, you extract and load it, and the data is there on a monthly basis. You don't have daily data there. Every month you just have a monthly data. The data is split by month. So it's kind of, again, do we have a scenario like that? Yes, we have. And do every company has a scenario like that? Not many organizations might like that because, they might not have users that would like to do the analysis like that. It all depends on the scenario. So again, accumulating snapshot is another example. You have monthly periods you need, but you want to accumulate it every day, and then at the end of the month, push it to the monthly bucket, and then it is there. So it's a strategy, different way. But a fact table is a fact table. Whatever you do, you just have the data that you are trying to measure your business. Okay, hope that point is very clear now. Okay, this example we touched already, and the reason why I put this example here, retail grocery business here. So you have retail sales. The grain is a point of sale line item. So that means a point of sale. So what you purchased in what day, what time, what product, what is the price of the product, what is the total price, what is the taxes, everything will be there on that line of POS line item. And you're going to store the data in a fact table. What are the dimensions? Date, which store you bought it, what product, what promotion. We just left it there. So that means you have 4 different dimensions that you're going to analyze. So you can see clearly what products are sold on what promotion, and what products are sold in which region, and what stores are doing great with this product, what stores are not doing well, how can we promote this product in these stores. Okay, if a store in the northern region is doing really good, 10 miles away from that store, this store is not doing good, you can go and tell, hey, what this store is doing, why you can't do the same things. You can also improve your sales. Those kind of things. You can do a lot of analysis, promoting the business model, driving your profit margin, driving your bottom line. So at the end of the day, this is a good example that we can think. And what are the different facts you could have? Quantities, dollar amounts, costs, and profit. So these are the different things that you could. This is a calculated value, probably gross profit, because you have a cost and sales. Subtraction of that, difference of that will give a profit, a positive or negative profit, whatever it is. So again, this is a calculated figure, and these are all natural, the value that they come from the operational system. So again and again, I'm telling you, so you should visualize, you should start thinking when you're building a data warehouse, you're building a data warehouse at certain goals. The goal is how fast you can give the data, how well you give the data to the business so that they can run their own reports. And once you build the data warehouse, and don't expect them to come to you for reporting creation. If that is the case, there are some data warehouses we still do that. We still build some, reports for my users, but that means we are not elevated to the higher level here because our users are not trained enough or something like that. So we need to educate them. So it's one of those things, If you can educate your users as part of your project, and then you can also save a lot of effort in the long run because they don't have to come to you for reports. They can do their own reports. Okay, so again, this example here, by looking at this, you can do a lot of analysis. and you can clearly see what are the dimensions, what are the fact tables, and we will go to another example. Then we will see why this example is important. And we also seen this last lecture. Just use the same slide. There's nothing different here. You have fact in the middle of these 4 dimensions. Okay. And I think one of you asked if we have order number, that will stay right here. Order number or line number or item number, whatever it is. Okay, order line item. So everything will be right here, right in the fact table. Okay, some of the examples here you can see here, day of the week. These are the different date attributes that you can have that you can do analysis with, and then possible product attributes. And again, you can see here there are different hierarchies here. Okay, so each product will have a different hierarchy. Same thing, store will have a different hierarchy like city, state, country, zip. This is a hierarchy, so you could have. Okay. There's another point that I would like to highlight before we jump on to the next topic is the factless fact table. So what is a factless fact table? Okay, so basically a fact is a measurement. Okay, so I hope it is clear now. A fact means a measurement that you will have to analyze your business. Okay, so in this example here you see there's a date key, course key, student key here, professor key, and room key. There is no value here. This is an example I took it from our textbook chapter 10, as you can see here, 10.12. So what we can see here is, in this example, the author is trying to tell us, let us say a student is enrolling a class from a professor on a certain day, and the course and the room that he is going to come and sit. Okay, so for this class. So when that happens, so it's basically, there will be an entry here, or when a student comes into the class, attendance. Okay, there is an entry here that means student attended on a day for that particular course, particular student ID, and whatever professor is teaching the class and the room he is attended the class. So this could be an attendance. So the reason why we didn't have any measurement here, if I'm trying to capture attendance, so what will be the value here? If a student comes here, the attendance is 1. The next day, 1. I attended. So by storing another value there, it doesn't give any result for us. If I say distinct values from this for a given day, or a given month, or a given course, will give the attendance of the student. If I give a student, okay, if I take the student, search for the student, and distinct values for this student, for this course, will give me the attendance of the student for that class, distinct count. Okay, I don't need to have another row here, another value here, and then add up those values. Okay, the presence of the row itself is a value for me, a unique value. So because of that, when that scenarios happens, again, there are some good examples, and this is a very good example that we have used in our organization, because again, this is our textbook example. Okay, so that's why I want to give you a flavor here from my own experience and what our textbook gives. This is a good example, no wonder, because it clearly explains where is the benefit of a factless fact table. And this is another example where I can give you another good example that, let us say I have introduced a promotion, okay, and this promotion is run for 3 months, okay. So what's going to happen is when I have a promotion, I have introduced this promotion to all my dealers. If I have 1,000 dealers, all my 1,000 dealers are signed up for this. But out of those 1,000 dealers, only 500 of them have done some transactions. Okay, so my fact table is a transaction-based fact table. So only those 500 dealers that were involved in the business with that promotion will have an entry in the fact table that have my transaction. But if I want to do some analysis, what are all the dealerships that were enrolled but didn't participate in the promotion? How do I know that? It's not easy for me. So that's why if we have a factless fact table and I create a promotion table, promotion fact table, so which will have entries for all the dealerships. That means all the dealers are enrolled. Sometimes out of 1,000 dealers, only 800 of them enrolled. So now I know the dealers that are enrolled are 800. And if I go to the other fact table that has a transaction based, and if that transaction based fact table has only transactions for the 500 dealers, then I know the difference of this dealer count. I have 800 here, 500 here. The difference of that 300 dealers are the dealers that enrolled but didn't do any sales for the promotion. Okay, and again, These are the things that you create them only if you want to do this kind of analysis. And if you don't care, I don't care if a dealer enrolls in the promotion and if he doesn't want to. If you want to track whether he really did the transaction or not, I just want to give the promotion and then it's up to him to take or not, then you don't need the factless factory. But if the management want to see, okay, I introduced the promotion this quarter for 800 dealers, how many of them really took advantage of this promotion? How many of them didn't take it? And then you want to do the analysis of why they didn't take it. Okay, is there a problem? They didn't like my promotion, and should I change it next time? Okay, if I have 800 of dealers enrolled and only 20 of them took the promotion and ordered placement, that means the promotion is not attractive for majority of the dealers. That means some of the promotion that we created are not attractive. So you need to go back and think and then come up with a new promotion. I think that's how the salespeople work. I hope you understand. Some of you are in the sales organization. Okay, so every promotion that you offer, don't expect that people will accept it. Some promotions are failures, some promotions are really successful. So the management keep trying these promotions. In order for them to try these, they need to go back and look at it. Look at the data, statistics, data analytics. So that is why we create this factless factory. So hope it is clear for you. If not, we can take up a question there. Give me a few minutes. I will take up another. Let's finish this and then we'll take up the questions and wrap up the lecture today right on 9:30 my time. Okay, the confirmed dimensions. Okay, before I go to confirmed dimensions, I want to introduce this new another star schema here. It's kind of inventory snapshot. In this case, we're trying to do store inventory. The green is daily inventory of the product and the store. Okay, so daily inventory. So what are the dimensions for this? Date, product, and store are dimensions, and fact is quantity on hand is your measurement. So now you see here, there is another fact table that you have a sales fact table that you have seen POS line item, point of sale line item is a grain, and here quantity on hand is a grain. So there are two different fact tables, and you're sharing the same date, same product, same store, and in this case there is no promotion, but in other star schema that you just seen before has a promotion dimension. So you can see here the three of the dimensions, date, product, and store, you have reused from the other star schema that you already have. So whenever you reuse a particular dimension within your data warehouse across multiple data marts, across multiple star schemas, you see here I'm reusing different terminology. They all mean the same. I also want you to think the same way because I don't want people to think, oh, star schema is different, data mart is different, data warehouse is different. Data warehouse could have one data mart or multiple data mart. In this example, if these two belong to one organization, I assume there is one data mart for sales, another data mart for inventory, and they're all in one data warehouse, and I'm sharing some of the dimensions between these two data warehouses. So these two data marts, these two star schemas. I spoke this probably 3-4 sentences continuously. I have 61 of you in the line. If any of you didn't understand what I said, that means there's a problem. Okay? I hope everybody got my point. But anyway, so these are the three dimensions. I call them as a confirmed dimensions. Okay? And again, the author Kimball and even our author from our Paul Raj, he also clearly explains confirmed dimensions and the importance of that. Okay, in many organizations, date is common. Products, you don't, if your organization, you make a product, whatever product you make, it should be in the product dimension. Okay, so if you're dealing with 100 stores, you keep all the 100 stores in the store dimension. Okay, so it's some of the dimensions are really you can share across multiple data marts because they all belong to your business. They're not bringing in some other business into you or doing analysis. So it's very important for those aspects. Okay. Anything that I said so far, if you didn't catch it, that means there's something wrong. Just ask the question. I'm trying to re-elaborate those points. Okay, so now we talk about dimensional model here. Again, it's the same example that we have seen in the previous slide here. A star schema, you have fact in the middle, of date, store, and product. Again, same attributes will be here. Don't assume that you have different attributes here compared to what you have seen other one. You are reusing the dimensions because they're confirmed dimensions. Okay. So again, trying to explain here same point. There's nothing different, so you can go through this. It's just exactly. And then this is the bus matrix. I think I already explained before. A bus matrix is a two-dimensional table. It's an Excel spreadsheet. Very simple terminology. Okay. I would like to put all the measurements, all the fact values here in the rows, and all the dimension values in the columns, so that I can clearly see when I'm doing retail sales fact table. This is a data mart. This is a star schema. This retail sales is joined with the date, with the product, the store, with the promotion. Immediately I can tell, I can do the analysis by date, I can do the sales by product, I can do the sales by store, I can find the sales by promotion, I can also find sales by promotion, by store, by product. I can also find what sales I did in January over February. I can also find what sales I did in this store versus other store. I can also do the analysis comparison between product category X versus product category Y, and why this product category X is doing better in this promotion versus other promotion. You can name it, you do it. Analysis. Okay? But the beauty of this data warehouse is you also have to give a tool for the business to do all this. I don't want the user come to you every time. I want to run a report. Can you tell me how I can create a report? I want to run a promotion, compare this sales store with this sales store. If they're coming to you like that, then it's a nightmare for data warehouse managers. You need to give a tool for them, train the tool for the business users. They should be able to do this analysis themselves without any IT help. Okay, so that is how we should design our data warehouse. That is the main thing that I strongly encourage, because I was in a meeting yesterday, in fact, with one of the business users. So one of the discussions that we had was they were telling, so give me the reports that you would like to have, and then I will give it to IT and they develop the reports. I'm thinking to myself, where are we going here? Still going back to 20 years. Okay, give me the analytics that you want. Do in your business. So tell me what kind of analysis you do. I will give a multi-dimensional structure for you, then you do the analytics. Don't come to me for a report. You create your own report. You export into PDF. You export into Excel. You export into whatever way you like, and you do everything. And that before we build something, you give me what kind of analytics you do. So that is what we should do. But again, the discussion that I had yesterday was they're coming out of the mainframe system. They're still in the mainframe technology, mainframe way of thinking. So they still have some reports that run in the batch mode and all that. So they were still, trying to capture everything. And I didn't comment in that meeting, but I'm sure I would like to slowly interject. Okay, as we capture the data, by looking at some things, I might suggest something. Hey, look, these are the 10 reports these people are asking. Probably we can create a multi-dimensional structure for these 10 reports, and that will give 100 different possibilities so users can do the analysis. Okay, so I'm going to throw that probably in the next couple of months down the road. I didn't say anything yesterday. So the reason I'm trying to say here is, in the data warehouse, there's a lot of opportunities in the space of analytics. Okay, so hope this lecture is really helpful for you. We took some examples. We tried to understand our concepts, what we studied, how it is different from OLTP systems, why we think different in data warehouse design, all those points, how we operate in different scenarios. I hope you got those points. I'm going to take the questions now. Before I take the questions, let me see. It's already 30 minutes past the second video. Let me take the break of that video and come back and take the questions. Again, those of you who have some things to do, I'm not going to cover any. So this is the last slide for this presentation anyway. So if you have the recording again, okay, that's good. Okay, good. So let me take up these questions. I know I'm paying attention to some of the questions. I'm answering those questions right away, but some of the questions I missed it. So let's see. In the meantime, if anyone want to ask a question that you would like to speak, go ahead and raise your hand, then we can unmute you. Okay. So we talked about degenerate dimensions is not going to increase fact table. Yes, they do increase the fact table, but if it is going to add value to my analysis, I'm going to include them. If it is needed for my analytics, I'm going to include that. Otherwise, if I don't have that, I can't do the analytics. So business is not going to be happy. So It's a matter of how we include them and then address the issues as we go. So I think Rajeshwari, we asked that degenerate dimension is part of the fact table. We already talked about that, and if you look at the textbook, it is a very good example there. You can go through that. Okay, we talked this. What is the difference between aggregate and the materialized views? Okay, aggregate is you kind of summarize table. Okay, I'm sorry, I didn't tell that. Aggregate means we're just kind of summarizing the data on a, let us say, you have data at the lowest level by daily transaction, and you can aggregate it to get the data weekly sales. Aggregate to the weekly bucket or aggregate to the monthly bucket. That means you're summarizing the data to a different level. Okay, that's basically what it is. Okay, a materialized view is a completely different concept. Yes, you could have a materialized view summarizing some things and putting there, but materialized views mainly used in a very few situations where you're processing something. It's kind of intermediate processing table. Okay, so you don't want to calculate. Let us say I am building some table here, and then I know that joining this data while I'm building with another table is going to be useful probably 10 minutes later in another processing, another job processing. So in that job processing, I know I'm going to join this table with other table. When I'm loading this, if I know that I'm already joined with this table, so it's better to create another entry into this materialized view. And then what's going to happen is when 10 minutes down the road, you don't have to rejoin again. So you can also use materialized views in your batch processing as an intermediate table. A materialized view is also can be used as, like I said, as a drop-down scenario for your reporting. So when you have drop-down choices, that are pulled from the database. So if you're trying to join from different tables, pulling these values as a drop-down, sometimes if it takes longer, then you create a materialized view and then use the materialized view to pull the data for the drop-down. So in different ways. So for sure, for you, I don't know the name here, but the difference between aggregates and materialized views, or there's a slight difference there. You could use a materialized view as part of aggregation, but aggregations are mainly built on top of fact tables, and materialized views majority of the times are built on the dimensional tables. Okay, joined with the dimensional fact tables sometimes, but mostly dimensional tables and extended tables and things like that. So materialized views, I think, hope it is clear. Again, there's no such rule that it has to be built only on the dimensional tables and things like that, but that is the most commonly used practice. Can we query from a cube instead of building an aggregate fact table? Can we put directly a cube in the data warehouse and query on it? Yes. Okay. Where do we get the cube is a question on the round. A cube is built on the data that you have in your data warehouse. Sometimes building this cube from a fact table might be slower, so you might build an aggregate table, a summarized table, and build a fact table on top of it. Sorry, build a cube on top of an aggregate table. Okay, again, these are all different strategies that we are going to learn in the next two lectures as we go. Okay, so yes, you're right. Why do we spend time and space building these aggregate tables? We do that so that we anticipate everything that we do here in anticipation of performance. Okay, for sure, if there is no performance gain, there is no benefit, we don't do it. Okay, just keep that in our back of our minds for now. So we build these aggregates. The reason is sometimes we have defined our design in such a way that I want to create the lowest level in my fact, so that future I don't have to go back and say to the business I can't do this. So you start with the lowest level, and sometimes you don't really need that lowest level for your analytics in the day one. So probably 2 years down the road they might need, but day one you know that it's already some aggregated, some summarized. So it is better to create a summarized table on top of it, build a cube, and then it will be faster and things like that. Okay, so we'll touch all those points, Anurag, but I think to answer your question, yes, I'm not telling you can't build a cube on a fact table directly. We have built those like that, and in many situations, we directly pull the data from fact table. It is faster and everything. But we also have scenarios where we build aggregate table, and that would be a source for my cube. So we have seen that also. So it's a possibility. Either way. Abhitesh, does the dimension table and the fact table share a primary key? Um, I don't know how I can answer that question, Abhitesh. Uh, there is a primary key in the dimension table, okay, pulling the data from a dimensional table. And, that particular primary key is going to be part of your fact table primary key if there is a transaction for that particular record in the dimension. Okay. So again, as you see, the fact table is a measurement table. If there is no measured value happened for that particular dimension, that particular key doesn't show up in your fact table. Okay. So you could have 10, like an example I gave the promotion. You could have 1,000 dealers entered in the promotion, but you could have only 500 dealers participated in the promotion and ordered some products. That means only those 500 dealer values that actually participated in the promotion will be entered in the fact table. That means those keys will be entered in the fact table, but remaining will not be in the fact table. They're only there in the dimensional table. Hope that example now helps you also, Abhitesh. Let me know if it's not clear. I can come back with a different scenario. Michael, is it right to think that tables are created more often based on changing requirement, business needs, and more or less they are static as modeling done was very good? Okay, that's a good question, Michael. Uh, yes, most of the tables, most of the fact, dimension, aggregation, all of these tables, I will give a good example here. Okay, we built this data warehouse table, data warehouse in 2001. I said, we have built from scratch. We built an inline approach. We built it, took almost a year and a half, and we built it. So after we built the data warehouse based on all the requirements, we built aggregate tables, fact tables, dimensions, and all sorts of tables, whatever we talked so far. And if you answer your question, Michael, how many new tables we created after that in the last, how many years? 14 years. Okay, probably we have created some new tables 5 years after we implemented. After 5 years, I could really think from 2006 to 2014, probably we might have created in how many 10 years we might have created 10 tables at most. That is, I'm not sure because I'm not managing the data warehouse, but again, those 10 tables might be for a new business process coming in, whatever it is. But it is not that common that you go and build these new tables on the fly. That's why it is very important for the requirements. It's very important in your design thought process. So as long as you do these things very carefully, thinking through all the scenarios, then you really don't add more new tables every time when something comes. So that is why I was telling, build the lowest level of aggregation, think through your process so that you already know what business is going to get in. Based on that, you can design your data warehouse. Hope I answered your question, Michael. Not rephrase your question. Can you represent a cube in the form of a 2D table which has aggregations and what is called? Okay, a multidimensional cube, we're going to talk about that, a cube, multidimensional structures. They're completely different concepts. We're going to talk about those in the few lectures here. I think probably 2-3 lectures down. It's a very interesting concept. Especially when we build a multidimensional cube, it's actually a flat file with again there are different companies, the different products that will allow us to build this multidimensional structure. So Cognos is one, VBEX Business Intelligence from SAP is another one, SAP BW is another one, Business Object, different software tools that will allow us to build these multidimensional structures. And we're going to talk about this in the coming lectures on the dog. I think cubes are better for self-service. Ayush Singhal, yes, the cubes are better for self-service. They can do multi-dimensional analysis themselves. But also, we have built some reporting tools, reporting what do we call as a data model or whatever it is. We build something and give it to the users, and then based on that, users can create their own reports too. Not only the multi-dimensional analysis, they can create flat report themselves. They don't come to me at all. I know they're creating multiple reports every day, but they never come to me, so it's a possibility. So not only just cubes. Cubes is one of the best ways, I'm sure, But like I said, yesterday's meeting, we didn't even talk about Cube, just talked about client reports. So there are some business meetings will be like that. So you will have to deal with those scenarios and try to give a structure in such a way that all the data objects get elements so that they can go and create their own reports. Okay. Manoj, how does the order number, invoice number help in analytics? Again, I told you, order numbers, if I want to do the analysis, how many lines, average lines per order number, if I want to calculate that, and an invoice number, I don't give I don't have exact examples for them, but for sure, there are situations where I would like to do the analysis, how many order lines I created in this month compared to last month. I'm sure people will ask that question. What is the benefit of that question? I don't know. They just want to see. And how these order lines, what is the revenue generated, and if I have less order lines, what revenue generated, those kind of things. Again, there could be a reason for that. Invoice numbers, what are the different invoices, how many invoices we paid in a given month, all those analytics, people would like to do, and what are the invoice numbers. If they want to see it, and if we don't capture the data warehouse, where do we get? Then I have to tell them, go to the OLTP system. I don't have invoice number here to go to the OLTP system. I'm sure management will not like it. You're giving me average invoice, average total and everything, but you're not able to give me the invoices. I'm sure people not like that information. Okay? So I'm sure it's there is a reason why we need those information, and I think it's better to keep them. Accumulating snapshot is nothing but aggregate, right? Okay, so accumulating snapshot is for entire data, but aggregations are based on specific hierarchy. So we're going to talk about that a little bit more just for when we talk about aggregates, it will be more clear for you. But there is a slight difference there for sure. What if I get to know, Abhitesh is asking another question, what if I get to know from a dimensional table that I need to fetch 10,000 rows from the fact table? Do we fetch them in a single query, or is there a better way? Because in class, she can perform well for large numbers. Again, Anurag or Abhitesh, who is this? Abhitesh. For me, when we are trying to deal with this, there are some SQL commands that are really faster. And again, the same SQL command that was not faster, I can make it faster by creating an index, by creating hints to the DBMS and all those things. So I don't want to go to too much close to that, how we can do it. There's a lot of things, a lot of better ways we can improve the query performance. We will touch those things as we go into the second half of this course. Okay. Michael, also does the data warehouse technical team works closely with OLTP, or they are two independent teams? There are some reports generated from OLTP and some data warehouse, like an example you gave for quarterly sales based on special scheme. Yes, most of the data warehouse teams work closely with operating system, OLTP system people, but data warehouse teams doesn't directly work on the OLTP systems. They have their own system. They have their own systems. They exchange information. They depend. If they need some information from OLTP systems, data warehouse can go and ask them, and the OLTP system give the data for them. And very few organizations have seen the same team working on both sides of the fence. It is a possibility, but if you have both same SQL databases behind the scenes, and then you could have the same team working on both sides of the fence. But I've seen in my experience, the operational systems people are different, data warehouse teams completely different. Again, if you ask me, do you have advantage by that? I don't see any advantage. It's just the nature of the operation that you have. Okay, man, that's perfectly timed. It's the last question I had, and it's right on the block. It's 9:30 for me here, and it's I think for you it's 9 o'clock in India. So I think right on the dot. Started right exactly at the time, and we're going to finish the lecture on time today. Again, thank you very much. I got to go because I have to pick my son. He's taking a SAT test today. But otherwise, everything is fine. So feel free if you have any questions. I'm sorry again. Last week I was a little bit I could not participate well in the discussion boards, but I will answer some of your questions on the Taxila forum. Okay. Have a nice evening, and we'll see you next week. There's no lecture tomorrow. Good night. Have a good weekend.